Hello, welcome to Math 1960, Section 301, Calculus 2, UNO Summer Session number 3. In today's lecture, we're going to discuss ratio tests and root tests. We're going to learn how to use both tests. So, theorem of ratio test. If you have a series of a sub k from k equal to 1 up to infinity with non-zero terms, if we take the limit of a sub n plus 1 over a sub n and we get L, if L is less than 1, the series converges. If L is equal to 1, the test does not provide enough information to determine whether the series converges or not. If L is greater than L, then the series diverges. If the limit of a sub n plus 1 over a sub n is equal to infinity, the series diverges. Okay, so this is our first example. In this example, we want to know whether these four different problems converges or diverges. So first of all, we need to determine from the first problem which one is my a sub n. My a sub n here being n over 4 raised to the power of n. A sub n plus 1 is going to be equals to n plus 1 over 4 raised to the power of n plus 1. So we take the limit as n goes to infinity of n plus 1 over 4 raised to the power of n plus 1 times 4 raised to the power of n over n. Limit as n goes to infinity of n plus 1 times 4 raised to the power of n over 4 times 4 raised to the power of n times n. The absolute value of that. 4 raised to the power of n and 4 raised to the power of n cancels out. So then we have limit of n of n plus 1 over 4n, and that should this is when n goes to infinity. That should give you 1/4. 1/4 is less than 1, so the system converges, or the series converges. Problem number 2 of the list. We want to determine what is my a sub n first. So my a sub n, it's equals to 2 raised to the power of n over n. A sub n plus 1 is equals to 2 raised to the power of n plus 1 over n plus 1. So limit as n goes to infinity of that 2 raised to the power of n plus 1 over n plus 1. N over 2 raised to the power of n. And then we say limit as n goes to infinity of 2 times 2 raised to the power of n over n, n plus 1 times 2 raised to the power of n. This cancels out. So limit as n goes to infinity of 2n over n plus 1. And that should give you 2. 2 is greater than 1. So the system here, or the series, diverges. Okay, so let's go to the third problem. So in the third problem, we have a sub n equals to 3n plus 1 over n squared, and then a sub n plus 1, it's going to be equals to 3n plus 4 over n plus 1 squared, and that should be equal to 3n plus 4 over n squared plus 2n plus 1. So limit as n goes to infinity of 3n plus 4 over n squared plus 2n plus 1 over times n squared over 3n plus 1. So, and then when we FOIL it out, we get limit as n goes to infinity of 3n cubed plus 4n over 3n squared plus 7n plus 5, 7n squared plus 5n plus 1. And when we take the limit of that, we get 0. So this doesn't give me any information. So if I compare this with some sort of a another function or another series, we will find that it converges. Okay, but this is not part of our work today. So we go to the last problem of these. We want to find the limit of uh, the limit of 1 over k factorial. So we are going to find a of n at this point, and it's going to be equals to it's going to be equals to n factorial a of n plus 1. It's going to be equals to 1 over n plus 1 factorial, and then limit of that as n goes to infinity, that would be equals to 1 over n plus 1 factorial times n factorial, and that should be equals to limit as n goes to infinity, and so n factorial over n factorial times 1 n plus 1. So n factorial cancels out. So then we are going to get we are going to get 0 here. So that means this thing converges. So the series converges at this time. The series converges. So we go to another ratio test. We do a ratio test here. So we have ace of n, it's equals to n factorial divided by n raised to the power of n. Ace of n is equals to um, n plus 1 factorial over n plus 1 raised to the power of n plus 1. And then when we take the limit as n goes to infinity of that, so we will get n plus 1 factorial divided by n plus 1 raised to the power of n, and so then times n raised to the power of n over n factorial. So then when we do the math here, we should get limit as n goes to infinity of some sort of like okay, so we are going to say at this point we're going to say n plus 1 times n factorial times n raised to the power of n over n plus 1 times n raised to the power of n times n factorial. So we're going to, this is n plus 1 here, okay? So then n plus 1 here is going to be n plus 1 raised to the power of n. So n plus 1, n plus 1 cancels out, n factorial and n factorial cancels out, and then here we have at the end limit as n goes to infinity of 1 over 1 over 1 over n. This is raised to the power of n altogether, or in other words, we are going to have limit as n goes to infinity of 1 over 1 over, and this is limit of this one is equal to e. So I have 1 over e. So 1 over e basically is less than 1. Okay, so then this converges here. So to determine the ratio test whether the series ace of k converges or diverges, we are going to use we're going to find ace of n. Ace of n at this point is going to be equals to n factorial over 10 raised to the power of n, and then ace of n plus 1 is going to be equals to n plus 1 factorial over 10 raised to the power of n plus 1, and then we take the limit as n goes to infinity of that. We are going to get n plus 1 factorial divided by 10 raised to the power of n plus 1 times 10 raised to the power of n over n factorial, and the limit of that would be limit as n goes to infinity of n plus 1 over 10, and that should be equals to infinity. So then the system here diverges, or this one here diverges. So regarding the root test, is similar. In the root test, we take the square, the nth root. Actually here I wrote this should be the nth root here. Sorry, this is the nth root. So we take the nth root of ace of n, and then if L is equal to 1, then the series converges. If L is greater than 1, then the series diverges. If L if L is equal to 1, then we